first order of moment, which is the conservation of energy. Let's first get this is a general form of a moment and order of moment, and the first moment basically can be counted as MSV. It's like an expression of momentum, and we plug this into the equation and multiply ms just because this is the momentum that we are used to see. So we plug this in here, So this is not a dot product. It's a vector multiplied by vector to give us a tensor, to give us a matrix, and plug this in as well. Then dv over dv obviously is 1, and we define the average of velocities u, and vv will have two parts. One is the average velocity, and this another part is kind of a thermal fluctuation, or a thermal is a velocity due to the thermal motion. It's a random motion, so this the average of w will be 0 because it's random motion. So it's not here, but we will have this in the second order average. Then we ended up having ui uj and pj over n as ms. This is a pressure tensor. So plug all those definition into this previous equation. We're left with this. So ddT ns ms u plus ddx ns ms u I uk plus pik minus ns qs e plus v cross b over c. And this is the average v cross b, as you can see, as an average over the density, the distribution. And this, we just define this whole quantity as Rs. S stands for species, of course. So this is a frictional force density. So let's have a physical understanding of each term. So the first term, obviously, as you can see, this is the density multiplied by the velocity is, and the time change of that, which is of course the change of momentum in terms of time. And this is kind of, you can think this is the momentum, and we have another a velocity here. So we can think it's kind of like gradient of momentum dot, not dot, sorry, like this. So you can think it's kind of like a flow. Like for me, I would like to think it as a kind of flow of a momentum, which you can see from the continuity equation. It resembles the current density. And this is a pressure tensor, and with a gradient, then it will become pressure gradient, which is a force. And this obviously is the electromagnetic force. So all of this, and this is a frictional force density. It's basically the change of momentum due to collision. So it's kind of like a friction in a way. So this is the change of momentum, and all of that essentially is force in a way. So except that this is flow of momentum, and this is a force. So you can think it's the second law of Newtonian mechanics in this. to a certain extent, which satisfy the conservation of momentum, and that's my understanding so far for this for the first order moment.